Tonight in this video, we're going to be looking at fractions. And actually, we're going to be looking at rational numbers. I want to start off with a joke for you. Why did the fraction 1/5 go to the doctor? You're going to have to wait to the end to find out the answer. Usually when high school math teachers are concerned that their students don't understand fractions, what they really mean is that their students don't understand how to perform the four basic operations, addition, subtraction, multiplication, and division, on the rational numbers. In order to understand what this set of numbers is, we must first build our way up to it. To do so, it's going to be helpful to think a bit about the history of math. How did we come to have the mathematical system that we do? Well, it seems clear that most cultures around the world have had some basic notion of counting that starts with a concept similar to our number 1 and then increases by 1 for a while, but not forever. Like 1, 2, 3, 4, 5. They didn't go on to infinity, but they went on for a while. The concept of infinity is fairly new to mathematics, so there's always been some highest number in other systems. But our natural numbers go on forever. In example 1, you'll see how that happens, how that looks, and how we represent it with the ellipses.
The natural numbers are represented with set notation using what we call curly braces. And they start at 1 and then go on from there, and we're going to use these ellipses to represent that it goes on forever. And then we end it with a closing curly brace.
The next set, whole numbers, introduces only one new number, 0. And whether that was created or discovered, I don't know, it kind of depends on how you see things or what the answer is, I don't know. But we're going to look at that in example 2.
There's no official way that we represent the counting numbers in mathematics, so I'm going to use this, the natural numbers symbol there with a sub of 0, showing that we also include 0 in addition to the rest of the natural numbers. And so it looks very similar to the representation of the natural numbers.
Each of the number sets grows out of a need for representing quantity in some new way, and we can see each extension of the previous set also is resulting from operations on the previous set. For instance, if we subtract a larger number from a smaller number, we need negative natural numbers. And this new set is called the integers. We're going to look at those in example 3.
With the integers, we can also use the set notation. I'm going to start off, though, saying that we go off to infinity in this direction. And then we have -3, -2, -1, 0, 1, 2, 3. I guess I put a comma there. I should put a comma there too as well. So the Z comes from Zahlen, the German word for numbers.
We have finally arrived at our goal, the rational numbers. This is the first set for which our representation has to be more complicated. Let's look at example 4.
And what we have is we're going to use some letters to represent numbers. So we'll use some number A over some number B. And then there's this line that is read as such that. So we have A divided by B such that A and B, and this symbol means in, so A and B are members of or are in the integers. And it also has to be the case that B does not equal 0. And so this is a set of numbers where A and B are integers and B does not equal 0. Because notice if B equaled 0, we would be dividing by 0, and that would be undefined. So that's how we represent the rational numbers. And the Q here comes from a word quoziente, probably mispronounced that. I believe it's Italian, and it's also related to the word quotient, which comes from German.
The formal representation can be scary and is the beginning of people's fear of fractions. What the symbols mean is that the rationals consist of all numbers that can be represented as fractions, where the numerator and denominator are integers, and the denominator is not 0. And I say can there because they don't have to be represented as fractions. But if they're able to be represented as fractions, then they're rational numbers. All right, you ready for the answer to that joke, the punchline? All right, let's hear that joke again. Why did the fraction 1/5 go to the doctor? Because it was 2/10. There you go. Have a good day, everybody.